The sun is one of the most observed objects in all of astrophysics, and with good reason. Not only does observing the sun teach us about the wider universe, the formation of stars far beyond our own, but it is also crucial for global security, because solar flares and coronal mass ejections on the sun can have impacts on satellites, power grids, and global communications. And so because of that, we have a multitude of spacecraft observing the sun at all times. And not only is this useful for scientists and space weather forecasters, but this data is also free accessible to the public as well. So in this video, I'm going to teach you how you can download data from spacecraft, satellites, telescopes in space and on the ground to make movies of the sun. So primarily, I'm going to be talking about some fantastic software called JHelioviewer, which is absolutely amazing at creating movies of the sun. But before I do that, I want to jump into a quick couple of alternatives that I'm just going to spend a few seconds on. The first is the Solar Dynamics Observatory instrument page. You can find this pretty easily just by Googling SDO the Sun Now. That's the Solar Dynamics Observatory. This is a NASA telescope in Earth orbit. And that will bring you to something like this. These are the most recent images of the sun in multiple different wavelengths. I'll talk about these a bit later on. But if you want to make a movie from this, what you want to do is go into Browse Data, put in your dates, a couple that I've already pre-selected here, select your wavelength, and again, I'll talk about these a bit later on in the context of JHelioviewer, and you have the option to either display the movie in the browser or to download the movie. The highest resolution you can do here is 1024 by 1024. Images are available in a higher resolution, but not through this nice easy GUI that we have here. And what that gives you, all in all, is a nice looking movie of the sun that looks something like this. A very quick and easy, far simpler than JHelioviewer. Another alternative to JHelioviewer, confusingly, is separate software called Helioviewer, so without the J. This software is currently down at the time that I'm making this video. It's not software, it's a browser, web browser. So this has the advantage you can do this from your mobile. You don't have to download any software. JHelioviewer is software. The functionalities between the two are very similar. I prefer JHelioviewer, find it easier to use. But again, if you prefer to use this, maybe I'll make a video on this in the future. But let's get to the good stuff, shall we? JHelioviewer. It's fantastic software being operated and funded sort of by the European Space Agency. Very easy to download, jhelioviewer.org. Click into download, select the model, select the version that is needed for your computer, and you're off. And when you open the software, it's going to look something like this. So, okay, there's a lot going on here, but immediately we can start to get rid of some of these tabs. We're going to minimize the timeline layers. We're not going to be using that. We're going to be minimizing the space weather event knowledge base. These are a selection of different databases. Some of these are useful. Some of them are a bit buggy and it's not super well integrated. So we're not going to be talking about them here. So let's close that as well. Suddenly a lot less going on, which is fantastic. The next things you want to do is remove the mini grid or remove the mini view. We will be removing the grid in just a moment, but I'll keep that on just for a second. And you're going to toggle on the timestamp. And you can now see there's a timestamp in the bottom left here. I don't have any data just now, so it doesn't really mean anything. And you can change the size of this as well. Move it to the top, add some extra information, whatever you want. And so here we have the sun. We have no data of the sun, but the software has put in place where the sun is. This is showing a grid of longitude and latitude on the sun. And you can see there's a bunch of numbers down here at the bottom too. Okay, so now we've introduced that, let's jump into some data. I'm going to remove my grid here for now. I'm going to click New Layer, and the first thing you're going to see if I just minimize this, these are the different sources of the data. So these are just the servers hosting the data. I'm going to go into IAS here. This is the one I usually use. I think this is the default. And let's click SDO, which is the Solar Dynamics Observatory, what we were looking at before. And let's click AIA 171. AIA is the Atmospheric Imaging Assembly. This is an instrument on board the Solar Dynamics Observatory. Let's click this in. And by default, when you load up the app, it will have dates set from the time that you open the app, or the last available data from when you open the app, to 48 hours prior. And normally, it would default to having 97 data frames within this range. At the moment, the Solar Dynamics Observatory has been experiencing some data server issues which aren't completely restored. So just to demonstrate this, I'm going to go back a year. Let's go back to January 2024. Let's just copy that in there. Let's just do the same date range, but a year ago from now. And let's sync this in like this. So you can type in your dates manually. You can click off the calendar here. These little arrows automatically move forwards and backwards a day. You can select a count and rotation as well, which is that unit that we talked about before. Has this loaded in? Still loading. By the looks of it, you can see, there we go. So the new date just loaded. We have 97 data points, which is the standard in this 48-hour period. Okay. So before I jump into what we're actually seeing here, let's use this as an example to see what these sort of toggles and buttons do along the top. I'll go through these very quickly. We have zoom in, zoom out, zoom fit. These do the same things as just sort of scrolling in and out with your mouse. I can also drag and pan around with my mouse as well. That's because we're set to pan here. If I set this to rotate instead, I'm now rotating around the sun. Obviously, our observations of the sun here are just from one angle, so if I rotate around, that doesn't necessarily do anything. But there are some satellites that do not orbit the Earth and orbit the sun independently, and so these can get images of the sun around the back of the sun, around the side, and so if you had both of these toggled at the same time, you could scroll between the two, but I'm not going to go too far into that. We have a reset view here, a reset axis. We can rotate around the axis. It does a similar thing to rotating sort of manually there. And the other one is we can rotate the view. This can be useful in the Z axis. Rotating just rotates around the plane of sky here. But if you rotate in any other axis, like the Y axis, you're just doing that rotation thing where we don't have data, so it doesn't particularly mean anything, right? Let's reset our view here and go back to normal. To make a quick demonstration, I'm going to change the dates here to be a bit longer. Let's do a period of 10 days now. This is 10 days in January 2024. Just to show you what some of these other things do here. This Corona tab is fairly simple. If you click this, it basically cuts everything outside of the sun's surface. So you're just looking at where the sun is. You're removing the Corona essentially. But this track function is what I want to point out here. So if I play the movie, and it is loading in, so it won't all play at once, but if I load it in, you can see the sun rotating, and then we run out of data there. But if we turn on this track, what it will mean is it will automatically sort of rotate the sun with, it's hard to sort of comprehend, we'll sort of rotate the sun with the point that you're tracking. So obviously, as this moves across the sun, the result of this is we sort of lose the edge of the sun. So not particularly useful if you're doing very long periods of time, but if you're doing a couple of days and you want to track a bright point, track the surface of the sun, you can put on this sort of track function. This differential function is weird again. What this sort of does is, because the sun rotates at different rates, at different latitudes, the equator rotates faster than the poles. So similar to track, it sort of creates a distortion effect where the forces the poles to rotate faster. Not quite sure why you'd want that, but that is always an option. We have this projection tab here. Again, you're always going to want this on orthographic. There's some weird stuff here, some different projections that perhaps are useful depending on your use cases. Log polar is pretty fun, I think. We have an annotation as well. Crucially, to do your annotation, you need to click Shift whilst you do your annotation. And you can draw a box on the surface of the sun, but this is a box sort of sticking to the sphere here. We have a circle, we have a cross. If you want to do a rectangle that's not sticking to the sun, you do this field of view box here. You can draw a line, you can draw a loop. Click tab there, you can draw a loop, all of this fun stuff. We have the refresh button here. It's not going to do anything right now. And these take you to some external websites that give you some data and some other observations in context too. So, okay, we have our observations. Let's jump in and have a think at what we want to look at. So I'm going to pick a date. I'm going to go April the 8th, 2024. And I'm going to go at 0:00. Now, if anyone remembers the 8th of April 2024, it was a pretty special day. Let's just do 24 hours there. It was the day of a total solar eclipse that crossed North America from Mexico through USA into Canada as well. So just for context, let's have a look here at what the sun was doing during the day of the total solar eclipse. Okay, and you can see by default it's loaded in these 97 frames here. If I want to do more than 97 frames, I can double click on my layer and I can actually change the time step here. So if I change this to 5 minutes instead of 10, you'll see when it loads in just a second, this is going to multiply by about 3. I'm going to have about 290 data points instead of 97. This is really useful. And sometimes as well, if you want to look just at a 5-minute period, the software will force a minimum time period of an hour, but double clicking on your layer and putting in the times manually here will fix that issue too. Okay, so here we are, 289 data frames from AIA 171. So that's the atmospheric imaging assembly at 171 angstroms. An angstrom is about 10, is defined by 10 nanometers. So this is 17.1 nanometers. For context, the human eye sees about sort of 400 to 700 nanometers. So this is way into the ultraviolet. Extreme ultraviolet is the term that we have for it. Let's add another layer. Let's add AIA 131. Let's add AIA 304 and AIA 211. And as these load in, I'm just going to double tap these and load in our 5-minute data, and then I'm going to wait for everything to load. Okay, so things are still loading in, but I'll get chatting while waiting for that. As soon as the first images start to come through, you're going to see something chaotic. This is 4 different images all stacked on top of each other. I can click the little tick box to remove them one by one, and here we are left with our main one again. There are 2 options here. You can view them layered on top of each other like this, or if you click this multi-view tab at the top, this will show them all separately, all individually. And data is starting to come through here. You can see I can load about 7 hours, 8 hours through the day. And this will continue to load as I'm talking to you here. But let's detoggle for now, and let's remove this multi-view. Let's say we have our 2 different wavelengths here, 131 and 171. Let's go for them. As you can see, we're overstacking them. They're not looking particularly nice. So what we can do is we can go into some of these options here and change with the levels. So changing the levels changes the lowest and top level of the sun here. You can also sharpen these features. I wouldn't necessarily play with the sharpening too much. You can go into 171 as well, do the same thing. Let's just brighten the background a little bit, just like that. And let's bring back the layers. And we can already see now we're starting to see detail from both, although admittedly it's not looking particularly nice. A reason for that is because we have a turquoise on top of the yellow. Doesn't look particularly good. So we can also change the color scaling here. So let's in this case change AIA 131 to, I know, lots of different colors. Let's go gray, and now things are looking a bit more palatable to look at. If we want, we can even change 131 to red. That's something I like doing, and now we can see here these 2 overlapped. What we can also do now is we can play with this blend and opacity function, and this just plays with the layering of the 2. So we can change our blend to be more towards the top layer, to be more towards the bottom layer. That's all that's doing. So at 100%, there's no bottom layer. At 0%, there's no top layer. And the same is true with the opacity as well. They're fairly similar, but you can play around with the two things here. Another interesting thing to click, let's go back to AA171 here, is these two tabs here. So this tab inverts your color table, so now things are reversed. The dark things are bright, the bright things are dark. And the other point of interest, this tab I really love. This amplifies the corona. So if I click this, watch the extra sort of information come here on the outer edges of the sun. So it's subtle here, but basically it applies a filter to make things brighter the further away they are from the sun, just to capture some of this detail here. Let's go back in, let's change this slightly to look something like that, and then I can make my movie. Essentially, I can play my thing with a quick look here. This is a day of things evolving on the sun. We have an active region over here. There's actually a prominence down here that I'll talk about in just a moment. But if I go into these options, this will actually give me the specs of the movie that I want to create. So I can change the frame rate to make the movie play faster. I can choose to just do one loop, keep going forever, just take a screenshot, and I can change the resolution as well. So AIA has a 4K by 4K resolution, so if you want full resolution, you should click this. Otherwise, you can click a lower resolution, or even just on screen is normally fine for most things that I'm using for. That's the resolution that I'm seeing right here, right? So this is all very useful. Another thing to think about is this difference tab here. This is fairly niche, probably won't be needed for a lot of you, but you have this option of difference, none, running, or base. If you take a running difference, this basically subtracts each frame from the frame in front. So if I just play this here, you're seeing where stuff is moving. This is great for pointing out waves and eruptions on the sun that might be more subtle, just because you see motion. Base is very similar, but instead of taking a difference between the most two recent frames, you're taking a base difference, so a difference to the image, the first image of your sequence. So what this means naturally is things start off looking pretty similar. There's not a lot of difference, but by a day later, everything is different, so it's not particularly useful in that way. So there you go. That's how you make a movie. I'll just take this as a quick example here. That is taking a screenshot. Let's just do one loop. And you'll notice it runs through a bit slower when you are recording. And after it's finished recording, it might take a minute or two for this then to be available in your directory. The default location, by the way, it creates a new folder in your top directory called JHelioviewer, and then exports, and that's where you can find your new movies. So here's an example of that, just to be complete here. We have a new folder right in my parent directory, JHelioviewer, and if I go into exports, this is where I can find all the movies. So here's an example, the one we just watched, 40 frames per second, 290 frames, that makes a video of about 7 seconds, and this is just at the standard screen resolution. So that's how you make a movie, but how do you know what instruments to use, what telescopes, what wavelengths to use? How do you know what to do? Well, let me explain that to you. But before I jump into that, I just want to do a quick plug of my book. It came out in 2023. It's called The Sun, Beginner's Guide to Our Local Star, and essentially gives a nice overview both of the science of the sun, but also the history of observing the sun, why we know everything we know today. And there's also a section at the end of how you can observe the sun for yourself, even with a little tutorial, a little bit like this one, of how to access spacecraft data from the sun. It is also available in a Chinese translation. I have no idea if the translation is any good. I can't read Chinese, but I can certainly recommend the English version. So, okay, let's jump in. What do these different things show? Well, a crucial thing to remember is that different wavelengths of light reveal the sun at different temperatures. The sun's surface is a lot cooler than the atmosphere of the sun, so produces different wavelengths of light, excites sort of atoms and ions at different wavelengths, and so the sun will look different at whatever wavelength that you pick. So for example, 171 here, let's just bring that back to the standard color that we normally have it at. This is looking at the sun at specific wavelengths that are sensitive to temperatures about 1,000,000 degrees Celsius. That's about 1,000,000 Kelvin, or about 2 million Fahrenheit. So that's what we're seeing here. This is the outer atmosphere of the sun, the corona, at about 1,000,000 degrees. AIA 131, as another example, again, let's just reset that back to the standard colors here. This is looking at the sun far hotter. There's a little bit of the cool sun in, but most of this bright stuff that we see, and especially during solar flares, and I will show an example of a solar flare a bit later, these show up very bright in AIA 131 because it's sensitive to temperatures around 10 million degrees, so far hotter. AIA 304, on the other hand, this is looking at far cooler material in the sun, at about 50,000 degrees. So this is sort of the upper chromosphere, which is a lower layer of the sun's atmosphere. And what you can see in 304, you can see things are looking a bit different, but instead of seeing these large loops, these large sort of outflows that you can see, and these loops that you can see here in 1,000,000 degrees, instead you're seeing cooler material. And down here is a very famous, this is called a filament or a prominence. This is a very famous one. This was visible to the eye during the total solar eclipse. So when the moon covered the sun and the sun was no longer visible, you can see the atmosphere of the sun. The atmosphere of the sun looks something like this, right? You see these large outflows, but also poking over the edge of the moon was this little filament down here, which was very cool to see. And the last one I'm going to talk about here, 211, is really great for looking at something called coronal holes. So coronal holes are lower density regions of the sun's atmosphere where plasma is flowing out really fast. This is the source of something called the fast solar wind, where plasma flows at about 700 kilometers per second, which is about double what it normally does. There's a small coronal hole down here, but every few months you'll see it makes the news that there's a large coronal hole on the sun. This is not particularly newsworthy. We see these fairly often. So these are the 4 that I recommend for making your movies. And again, be creative. Sort of change the colors of these, change the blends, the opacities to make a movie that looks good for you. Other instruments to consider. There are a few other good ones too. Let's minimize SDO here. And let's go into the Royal Observatory Belgium into Gong. And I'm going to click Gong H Alpha. So this is the only ground-based telescope that I'm going to be showing you here in this video. Gong is a network of telescopes basically all the way around the globe. There's 6 or 7 of them, I can't quite remember off the top of my head. And these are positioned such that as the Earth rotates, the sun is always in view. You can always see the sun. Now, H alpha is a very interesting wavelength. Amateur astronomers, if you have a solar telescope at home, you have the option of having a H alpha solar telescope. And this is looking again in the chromosphere of the sun, where you can see these very visible filament structures and all this furry stuff, which is just background detail of the sun, really. And I'm going to change my levels slightly just to enhance some of these features. But here we go. These are called... we talked about it before in the context of the edge of the sun, but these are filaments. They're often called filaments if they're on the sun. Prominence is over the edge of the sun, but they're the same thing. You can see there are some sunspots here as well, and these nice filamentary structures. This is a very good option, especially if you have an H alpha telescope. Always good to get some sort of professional footage of what is going on. What else can we see? Well, going lower down into the atmosphere, let's go to the sun's surface. Let's go back to SDO, this time to HMI. So HMI is an instrument that measures the magnetic field of the sun. So let's load in both of these whilst we are waiting. HMI continuum, HMI magnetogram. And the continuum is what the human eye would see, essentially. We're just looking at white light from the sun here. We have a very nice small sunspot here. Not a lot of sunspots. Let's remove that. Not a lot of sunspots here on the sun this day. And again, we can make this look a little bit nicer by adjusting some of these levels just to make the sunspot... My goodness, what have I done here? Sorry, not sure what happened there. Freaked out on me for just a second. But here we can see a few sunspots littered across the sun. And this is what the human eye would see. If you have a white light solar telescope, you will see something like this. If you have eclipse glasses that filter the sunlight so you can look at the sun safely, if these sunspots are visible, you can make these out too. And there are some nice detail here. You can see we have the inner umbra and the outer penumbra of the sunspot. And if I just click play, let's just look at a day of evolution. Let's zoom in here. You can see these things moving, evolving, outflows from the sunspot here. So pretty cool, especially if you look over periods of days or weeks. Now, as I mentioned, HMI also measures the magnetic field of the sun. This is a little bit more difficult to sort of explain what's going on. But essentially, all of the white regions here are regions of positive magnetic field, and all the black regions are regions of negative magnetic field. So you can see here, sunspots have very strong magnetic fields. The quiet sun does not have strong magnetic fields. I don't think this is particularly useful if you're trying to make nice, pretty looking movies of the sun, but measuring magnetic field is crucial for scientific research because magnetism is the driving force of everything going on the sun, really. Okay, so let's go with a final spacecraft here. Let's go to SOHO. So SOHO is a NASA mission that launched way back in 1995. Most of these instruments in SOHO are no longer operational. The two that are LASCO C2 and LASCO C3. Let's load these in here. Now, this is something a bit different. This is called a coronagraph. The first thing you'll notice is I've loaded it in, and there's nothing here, right? Why is there nothing here? If I load in the grid, right, the sun should be here. Why is there no SOHO? You've got to zoom out, because SOHO doesn't observe the sun itself. It measures the atmosphere of the sun. It has what's called an occulting disk, has a black disk that blocks the sun to allow a view of the wider atmosphere of the sun. And we have both LASCO C2 here, which is looking lower down in the sun's atmosphere, and then LASCO C3, we can come all the way out and we can see really far into the sun's atmosphere. There's a very small eruption, oh, ignore that, a very small eruption coming up here, which is cool. And again, if I look at these two, let's reorder them, and I do the blend, I can view all of the inner field of view, or I can just view the outer field of view if I change these around like this, right? Just so I can see one or the other. So again, SOHO is very good for looking at coronal mass ejections, eruptions leaving the sun. At the time of posting this, the beginning of 2025, this is the only operational coronagraph in space, but there was a new mission launched by NOAA, which is a compact coronagraph, which will be going live at some point in 2025, all things going well, which will mean that SOHO will probably be obsolete and slowly phased out. So if you're viewing this in the future, perhaps SOHO isn't there anymore and you need to use a different data source. But now we have all this data, and there's a lot of this data. Let's look at another example. Let's go from the 10th of May, actually the 9th of May. You can see if I put in a date that's sooner than the end date, it will automatically change my end date. Let's go a week. So let's go to the 16th, and let's click sync here. Let's remove a couple of these. Get rid of gong. Let's get rid of 304 to 11. Don't need the magnetogram. I will keep the rest, and let's wait for these to load. Okay, so everything's loading here, and immediately there's a lot going on, right? We can see a couple of eruptions coming from the sun. These are planets, I believe Mercury and Venus, although I can't remember which way round these are. But let's zoom in and look at things one at a time. HMI continuum, let's start here. Suddenly the sun is looking very different to how it was on the day of the eclipse, right? We no longer just have these small sunspots, we have this colossal sunspot region here. Now, sunspot regions have numbers. This is active region 13665, and it's a very famous region. This produced a lot of Earth-directed coronal mass ejections, one of which caused, or a combination of which, caused a extreme geomagnetic storm, which is what happens when stuff from the sun slams into the Earth's magnetic field, and it caused the aurora to be seen from all over the world. There's millions of people saw the aurora for the first time because of a solar flare in this region. If I click play, we can look at the evolution of this as it evolves. I am tracking. Let's get rid of the tracking. And there you go. You can see the evolution here. This is a week, and you can see all these smaller active regions and sunspots also popping up as well. In AIA 171, looking at the atmosphere of the sun, looking at a week's worth of data. This is our very large bright active region over here that disappears off the edge of the sun, and all these other things are new bright active regions that are rotating across the sun too. But the thing of interest, for me at least, let's have a look at some solar flares. So again, remember, this is the wavelength most sensitive to solar flares. There are two, but this is the best one I recommend. And here we have an example here. Now, I'm not going through with a particularly very fine resolution. Maybe I should increase that. But we have a few examples of solar flares all the way around to the edge of the sun. We have another big solar flare here too. This is a nice big solar flare on the edge of the sun. So again, I can combine these two together. Let's change the wavelengths here. Let's put red there. Let's go with, let's keep that blue. Let's change that a little bit. And you can see we're really saturated. That's how bright solar flares are. They can be really tricky to observe. But here we go. So here's our nice solar flare taking place on the edge of the sun. And if I wanted to make a better video right now, what this is, well, an hour 45 between these two frames. So I can go down all the way to 24 seconds if I wanted to get a really nice resolution image. In fact, here is one that I made at the time. Here's a nice movie to show what this flare looks like from the 13th of May. But if I zoom out now, let's zoom out a little bit. Let's bring these back online. Let's bring in LASCO. We can get a closer look at these coronal mass ejections. There are a lot of them. This fuzzy snow that you see, these are energetic particles hitting the detector from these solar flares. And you can see this region just produced CME after CME after CME. These are ejections of mass from the atmosphere of the sun. So to summarize, SDO, AIA is useful for imaging the sun's atmosphere. HMI is interesting for looking at the surface of the sun. We have, what else do we look at? GONG is a ground-based telescope for looking at H-alpha for comparison to telescopes that you might have. And finally, SOHO LASCO is great for looking at coronal mass ejections. And so there we go. Thank you very much for watching. Hopefully this was useful. If you have any interest in downloading these data and making nice movies, I just think it's a really fun thing to do. If you have enjoyed this, I am relatively new to making content here and do want to take it more seriously in 2025. So if you could subscribe and even comment and like just to tell YouTube that you are enjoying it would really help me out. So thanks a lot. See you next time.